OpenAI just released a huge new update to their API for getting structured output. And in this video, I'm going to walk you through everything that you need to know. I will be showing you some code examples, which I will also share with you so you know how you can effectively use this to build your AI systems. Now, for those of you that are new here, my name is Ebbelaar. I'm the founder of Data Lumina, and I've been building custom data and AI solutions for the past 5 years. And I also create videos like this to help you do the same. Now, let's get into it. All right, so the new structured output in the API. Now, like I said in this video, I will be walking you through some of the highlights, but also really go beyond just the blog post that you can see on the website. And then, of course, also share some code examples with you, because that's why you're probably here, because otherwise you could have just read the blog post from OpenAI. So we'll really get into some specifics. I will also share the code with you. So really at the end of this video, you really have everything that you need to know in order to get started with the structured output in your projects. And now, quick note, like I've said, we'll cover some theory here first. Now, if you're just here for the code examples, feel free to skip around using the timestamps down below. But I recommend watching this first half as well to really get clear on when to use and how to use structured output, and for example, how it is different to function calling and what the different modes are that you can use. Now, for some quick context, what does this new update introduce? Previously, if you've already worked with OpenAI API, which I assume because this is a pretty advanced topic, you might have been aware of the option to either do like function calling or use JSON mode. I created a whole video on this, which I will link up here. You can check that out. So if you want to know all of the specifics for that, you can refer to that. But the problem with that was, while, for example, JSON mode would basically, OpenAI would give you the guarantee that what you would get back from their API was a valid JSON schema. Meaning, in simple terms, if you would put it into a JSON loads in Python, it would load and it would not give an error. But it could not give you a guarantee on the actual content within the JSON schema. So for example, if you were using an enum, then it could still hallucinate and come up with an entirely different category, for example. Now they fixed that. So in their blog post, they explain the new functionality and also from some benchmark perspectives. And they claim to have a perfect 100% score on their benchmarks, on their tests. So this is going to be a major improvement and will overall really improve the quality of the systems that you're going to design using OpenAI's API. So here's a quick visual representation of this. So with the chat functionality that we all started to work with, you would ask a question to the API and you will get a string back. For example, hi there, how can I help you? And then with JSON mode, you could enforce a JSON object to get that back from the API. But then, for example, category could still, if you prompt it in some way, category could also be class all of a sudden. That could happen. Now, with this new structured output mode, we can guarantee that if you have the keys, for example, message, sentiment, category, then that is what you will get back. And it goes beyond the keys. We can also do this with the values. So here, for example, they are all now strings in this simple example, but we can also use other data types here like booleans and enums, which we'll get into in a bit. And now if you watch some of my other videos, you know I'm a big fan of the Instructor Library, which essentially just this, structured output powered by LLMs. So if you've already used Instructor, this new OpenAI update is not necessarily going to provide you with any new functionality other than the fact that we can now do it natively with the OpenAI API. Plus, we also have a new model that is more optimized for these tasks. So there's a new GPT-4o release, and that is going to overall improve the accuracy. So I run some quick tests, which I will also share in a bit. And the workflow seems almost identical to using Instructor. But I imagine that under the hood, you would have less retries and the model will get it right the first try more often. So overall, I think this is a major improvement and a step really into the right direction, having this all natively within the API. So 3 major benefits that we get with this new update is reliable type safety. So we better understand the data that's coming into our system and how to process it. We also have explicit refusals, so we can detect safety-based model refusals programmatically. So for example, violent language, and this is excellent to counter prompt injection. And we have simpler prompting, so achieve consistent formatting without complex prompts. And this really is a big one, which I will show you in a bit, especially if you are working with larger teams. So now let's cover 2 more quick theoretical points, and then trust me, we'll get into some code and actually show you how this works. But it's important to get the full context of when to use this, how to use this. So structured output versus JSON mode. In the beginning of this video, I already explained that JSON mode was already available. I think this is very simple right now. This is a recommendation from OpenAI. Use the structured output whenever possible. JSON mode is probably going to be a feature that's going to be deprecated over time. You want to use structured output. So that's a simple one. But now then, when to use structured outputs, and if you're going to use structured output, when should you use function calling and when should you use the new response format? So this is the new update, which I will show you in a bit. Function calling was already present in the API. I did a whole video on that as well, which I will link up here. If you want to learn more about specifically function calling, check that out. But here are some general guidelines from OpenAI themselves, and I added one extra summary point to this. But in short, if you are connecting models to tools, functions, data, etc. in your system, then OpenAI recommends using function calling. So meaning you want to get some parameters that you can then directly plug into a function or in an API. That is when function calling is recommended. But if you want to structure the model outputs when, for example, you respond to the user, then you should use the structured response format. So this is what they recommend. And I would add one more thing here, that if you're building multi-agent systems or pipelines that require internal routing or like intermediate steps in a chain of sequences, I would also recommend using the response format. So this is what we're doing internally for all our projects at Datalumina, and we've been doing this for the past months, and it works very well to get that data object and then define various parameters or fields, for example, booleans, enums, and based on that, decide the next step within the system. So that is what I would add to this summary on when to use the response format. But now with that theory out of the way, let's get into how to actually use these structured outputs. And like I've said, I will be walking you through some examples here. The code will be made available to you. And now let's get into the examples. And currently there are 2 ways to use the new response format to get structured output. So you can use a JSON schema or you can supply a Pydantic model. Now let's take a quick step back here, because as you can already tell, there are a lot of decisions here that we have to make, right? First, it was when to even use structured output. Then if we're going to use structured output, when to use function calling and when to use the new response format. And then if you decide to use the new response format, which I recommend for the following cases, then there's also another decision to make, and that is, are you going to use a JSON schema or a Pydantic schema? So I'm going to explain both steps and both ways to you, but I already want to point out, I would definitely recommend going with the Pydantic route, using Pydantic, and OpenAI themselves, they also recommend this. So OpenAI recommends using this method whenever possible. I'll show you why in a bit, but for context, we're going to start with the example with a supplied JSON schema. So you fully understand how this works behind the scenes, and then we're going to make it simpler using Pydantic. So in order to follow along, make sure that you update your OpenAI pip package, make sure it's up to date, and then also make sure you use the newest and latest model. So I'm going to be walking you through this example query over here for a customer care ticketing system. So I'm having trouble with a recent order, etc., asking for a return or refund. And next to that, we have also a simple system prompt that is instructing the model to not only give an answer to this question, but also walk through the steps and actions that the system or AI needs to take in order to answer that question. Now, this is a really good example of, for example, how you can create a AI customer care ticketing system and also want to store some internal data or metadata to basically study the reasoning of the AI. So whenever the AI sends a message that turns out to be wrong or not an ideal answer, then you could look back into the system and look into the reasoning, and through that you can maybe adjust your prompts. So let's look at how we can provide such a JSON schema. So top level here, we have nothing new. We have a simple chat completion. We provide the model, the messages, including a system prompt and a query. And then here we get into the response format, which we can now set of type JSON schema, followed by the actual JSON schema, and then some final parameters that we can plug in here. Now, I'm going to walk you through the structure of this response format, but I always like to explain things through reverse engineering. So I'm first going to run this and show you the output and then reason back to see what we got going on over here. So let me actually see, so you can show this. So we get the response and we walk through this in a loop and we print the various steps. So remember the ticketing system, we got a question and we have a system prompt. And now next to just creating a single reply to the customer that we can then send back, we have various steps and actions in between. And then we have the final resolution. So this is really interesting where the steps and the actions could, for example, be part of the internal process of the system where we either store this as metadata or based on various steps and actions, we decide what kind of information to get from another system or what route to go or what agent to call. And then eventually all the way we have the final resolution, and that is then what we send back to the customer. So that is what we have right now. So let's see how we got to this point by zooming in on this JSON schema that we got going on over here. So we start top level and we say, hey, this is an object that we want to create and that object has some properties. Now, like we see, we have steps, we have actions, and we have the final resolution. Top level, you can see those keys over here. So we have steps, we have items, we have the steps, and steps is of type array, and these include the description and the action. So that is the step and the action. So here's how that nested JSON schema is defined. And then also we have the final resolution, which is a string, and this also has a description here. So the final message that will be sent to the customer. Now, to zoom out a little bit, this, if you're new to this might seem a little bit complicated, but this is just like a simple JSON schema and you can define this in infinite possible ways. So you can also use different data types. So you can use arrays, you can use strings, but you can also use integers, you can use enums, you can use booleans, you can use almost all of the most common data types that you want to use, that you would want to use in a system like this. And to decide what the ideal structure is for your specific project that you're working on, you should really zoom out and really think about what is the kind of data that I would like to get from the system and how am I going to use that? So for example, do I first want to create a category, which could be of a type enum? And for example, let's say you have 3 categories and for each category you want to kick off a different pipeline or different processing pipeline. Then when building an agent system or pipeline, defining that category would be the first step within the system. And then based on that, you would trigger follow-up actions, each building on top of each other. So that's really how you should reason about designing these JSON schemas. And also, if you're new to working with JSON schemas like this, a simple trick that you can do, just plug this example into ChatGPT and ask it to create an example or adjust the schema for, and then fill in your use case. And then lastly here, what we see is we have some additional parameters to play with. So for example, required additional properties, we can adjust those as well at various levels of our JSON schema. And then here finally, we have the strict parameters. So when we set that to true, that basically tells the OpenAI API, this is what we want and nothing else. So that covers how you can start building your own JSON schemas and then supply it to the API. And then finally, let's have a quick look at the responses over here. So what we get back over here from the API in the message is a chat completion model. And let's see if we have a look at that. You can see it contains some content. We also have a refusal here. We have the role, the function call, and the tool call. So there's additional data here that we can use. But the content is a string that can be parsed as JSON. So then in order to use that inside of our system, we call the JSON loads on the response.content. And that is where we get the nice structured output that we can then use to run these steps and print everything. So that's how it works under the hood, also considering the data types that you are getting back from the API. All right, so now that you understand the first method, providing a JSON schema, let's get into the second way that you can get structured output, which is what OpenAI recommends. And I would recommend this as well. And that is using the parse helper function and providing a Pydantic model. So this is currently available as I believe as a beta feature, because we really have to call client.beta here. So this might change over time. So let's get into how this works. Now, if you are new to Pydantic, I would highly recommend checking it out, going through the quick start and understanding what you can do. But it's similar to Python data classes, but it also allows you to perform data validation. And I highly recommend getting deep into that library if you're building AI systems with Python. But even if you're new to it, I will try and explain it as simply as possible here. But what we can do with Pydantic, which is it's a pip install, and we can then import the base model. So let's go over here. So here you can see from Pydantic, we import the base model and then also the field, which I will explain later. So that's how it starts. And that allows us to define Pydantic models. And Pydantic models are data classes similar to what's already pre-built in Python. But then, like I've said, it also introduces data validation. And we can build that JSON schema, that data model that we've previously defined. We can also build that using Pydantic. And the code that is highlighted over here does just that. And we can already see some of the benefits over here. First of all, it's a lot shorter. It's much easier to read because we can leverage a lot of the abstractions that are either already available within the Python programming language or in the Pydantic library. So let's have a look at this model. So top level, we define a class similar to how we would normally define a class in Python, but then we inherit it from the base model that is imported from Pydantic. Then in here, we create a subclass because, as you can see here, the array that we have also has some properties, and we can create these nested data structures over here using that. So the step again has a description and an action. And at this level, we can also then again provide another description to what this field actually means. So this is your prompt engineering for the AI. And then we define this data class as a collection of steps and a final resolution, where steps is a list of the steps that are defined over here. So if you're new to this, the syntax, you have to get used to it a little bit. It's not that hard. Go through the quick start, some examples, but this is how you can define such a model. And now what we can do when we get to the actual inference and the call to OpenAI, all we have to do is put in this data model as the response format. So we really drastically reduce the amount of code and complexity that is required in order to make this run. So let's come back to the code over here. So here we have the first example. Now we get into the Pydantic example. So here we have the class. Now we have the other function, and let's get the response from the API. And then one important thing to note is what we're getting back is already a Pydantic model. So by providing this ticket resolution model, what OpenAI will do is it will get the response from the API, but then also put it into this object already. And this also removes the extra complexity and step of first loading it via JSON. We immediately get that model back, and we can then use it in our system. So we can dump this as well, and we can see we have all of these steps, actions, and the final resolution in here as well. So if we now, for example, want to send the final resolution to the customer, for example, this is how we would then query that key within the model. And here you can see, let me make this a little bit larger for you. Here you can see the final resolution. And what I absolutely love about working with AI systems like this from a system design perspective is how easy it is to extend and adjust. So let's say within this processing pipeline, we also want to add a confidence score, and based on that set a threshold where if the AI is, let's say, below 0.7 in its confidence, we don't send the message to the customer, but we escalate it to a real agent. What we can then do, it's as simple as adding another field here. So we said confidence, this is a float, and we give it a description of what this should be. And then let's update this ticket resolution class and run the system one more time. And then we have that confidence score over here, which we can now use to, let's call that confidence score. We have that. And for example, we can create if confidence score below 0.5, or let's say we said 0.7, do X, do Y, whatever. This is how you can use this in your system design. It's as easy as providing a different field, giving it a description. That's your prompt engineering, and you're good to go. Now, one quick note for people that are already familiar with Instructor. One small thing that I found, which is kind of annoying, is that currently it doesn't work with, for example, greater than or less than parameters in a float. So there are most likely more validation parameters in the Pydantic library that currently are not supported. And this does work with Instructor. So what if let's say we run this, we will get an error from the API, and it will say something about the properties confidence minimum is not permitted. Well, they do explain here in the docs that it is supported within the JSON mode. So within the JSON schema, you can define certain parameters. So currently this is not supported natively with Pydantic, so I hope that they will update this soon. So that's how you work with Pydantic models in the response format. So make sure you use the beta over here, make sure you get the parsed variable, and then also ensure that you're using the latest model and have updated the OpenAI client. And with that, you can get Pydantic models straight from OpenAI. Below in this script are also some examples with enums which you can run through on your own. So here's an example that I previously run in an instructor tutorial. And then also here's another text summarization one. So this is a really cool one from an OpenAI cookbook. So you can see how you can scrape information from Wikipedia and then parse that text and get the invented year, the summary, the inventors, the descriptions. And here you can really see how you can build quite complex systems and capture knowledge in a very structured way based on unstructured input. Very powerful stuff. So then to conclude with some tips for working with structured output, I recommend always using the Pydantic models over supplying the JSON schema when possible. It's shorter, easier to parse, instant validation, like we've seen in this example. Also use proper descriptions for all fields. So when you're using, for example, Pydantic, over here, let me show you, use the descriptions. This is your prompt engineering. This literally tells the model what it should put in there to ensure the reliability of your system. And then also make sure to mix and match different data types. So booleans, enums, etc. are really great for system design. So true, false, should we escalate, what category is it, etc. And then finally, I want to conclude with how I currently see this next to the Instructor Library. And I am not sure yet. So like I've said, all of our current systems that we build for our clients and the products that we have, they use Instructor in the backend right now. The fact that there are some limitations on the Pydantic models, to me, indicates that probably I will still use Instructor right now, but I am going to upgrade to the new GPT-4o model, which will likely improve the performance. But I will probably wait a little bit for this to stabilize, to switch everything and continue to experiment. And I think also one important thing to understand is that Instructor not only works with not only works with OpenAI, but it also works with other model providers. So it also works with Anthropic. And what we often do is, in some projects where the kind of model that we use doesn't really matter and we just focus on the best possible performance, we create a simple like LLM factory where we can basically pick different models. And Instructor allows us to simplify and streamline that process. Where OpenAI just released this new feature, the other model providers will likely follow because OpenAI really sets the direction here. But until that point, I think you're still good to go with using Instructor, and you can just leverage the better performance of the model under the hood. All right, and that's it for this one. Now, by the way, if you're a developer or data professional with already some experience and you consider freelancing, but you don't really know where to start or you struggle to find clients, then you might want to check out the first link in the description. It's a video of me going over how my company can help you with this. Now, in all transparency, it's a funnel designed to get leads from a company. So just so you know that, you of course don't have to click it, but if you consider freelancing, you might want to check it out. Then I want to thank you very much for watching this video. If you found it helpful, please leave a like and also consider subscribing. And then if you want to learn more about how we at Datalumina build, sell, and deliver our generative AI projects, then you might want to check out this video next. It's a video of me going over that entire process from start to finish.